Here we have an example from the practice test 2 that deals with a heavy object that is suspended underwater by a string, and the tension in the string is measured and known. So we basically have the surface of the water, and we have our digital force sensor and string, and then we have our mass there, and this digital force sensor is telling us 14.8, and we're asked to find the density of magnesium. So the first thing we need to realize is, what does the force diagram for our mass look like? So there's our mass. We have a force of gravity, and we're told that this thing has a weight of 34.8 newtons. We know that this thing has an upward force of tension is equal to 14.8 newtons, because this mass is touching the string, and that's what the string does. It pulls with a force of tension. And we also know that this thing is underwater, so there's water all around, and that water causes a force of buoyancy. So that's how I got this equation that says the force of buoyancy plus 14.8 minus 34.8 is equal to 0. The buoyant force is up, so it's positive. The tension force is up, so it's positive. And the gravity force is up, so it's, I'm sorry, the gravity force is down, so it's negative. So that tells me that the force of buoyancy is equal to 20 newtons. Now we want to relate that to the density of the object, because that's what we're being asked about. And the formula we use to calculate the force of buoyancy is that the force of the buoyancy is the density of the fluid times the volume displaced times g. So we have to think about the fact that this is a sunken object. So the volume displaced is equal to the volume of the object. Because the entire object displaces water. So then we should think about, what is density? Density is rho equals V. Whoa, no, it isn't. Rho equals mass per unit volume. Which means that rho times volume is equal to mass, which means that volume is equal to mass over rho. So let's put that in there. Let's make this rho fluid times the mass over rho. Now I have two rhos, two densities in the same thing. So this is object density. Times G. So let's rearrange this a little bit. Let's get rid of the fractions. Rho object times the force of buoyancy is equal to rho fluid times mg. Yeah, it's a lot easier to deal with without the fractions now. So now we have rho object. Force of buoyancy, do we know that? Yeah, that's 20. Do we know the density of the fluid? It's 1,000. And what's this mg? Do we know the mass of the object? No, but we do know the mg. The mg is the force of gravity. That's 34.8. So now we can solve for the density of the object as 1,000 times 34.8 over 20. So the force of buoyancy is proportional to the weight of the object. And the proportionality between them is related to the densities of the object and the density of the fluid. You could also take this thing and make it look like force of buoyancy over mg is equal to density of the fluid over density of the object. Because doesn't this equation up here, after I did this substitution, doesn't this look like the result of somebody doing a ratio analysis and cross multiplying? So they had just cross multiplied. So let's uncross multiply. Force of buoyancy, divide both sides by mg. Over here is rho fluid, divide both sides by rho object. This was the ratio that it came from. And this is force buoyancy over force gravity is rho fluid Vg over rho object Vg. And this is how I usually teach it in class.